Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Let me introduce myself. My name is Muhammad Randi Aisbakulu, NIM 4524-22040. I'm student Prodi Geological Engineering in Departemen of Universitas Negeri Gorontalo. Okay, first, let me explain about chemical equilibrium. Chemical equilibrium is a state when both reaction and products are present in the same concentration. Usually, this situation occurs when the forward reaction process at the same rate as the reverse reaction. The rates in the forward and reverse reaction are generally non-zero but the same. Chemical equilibrium refers to a state when the concentration of reactant and products do not change over time. This situation is irreversible, that is, it can react back to form reactants. This can happen when the rate of the forward reaction is equal to the rate of the reverse reaction. Equilibrium can be divided into two, namely static equilibrium and dynamic equilibrium. Static equilibrium occurs when all the forces acting on the object are balanced. No force is generated. Meanwhile, dynamic equilibrium is obtained when all the forces acting on the object are balanced, but the object itself is moving. Static equilibrium means that chemical reactions occur only in one direction, so they cannot return to normal. A simple example of static equilibrium is burning paper to ashes. It is impossible for the paper to change to its original form after turning to ashes. Dynamic equilibrium is an equilibrium that occurs in two directions, meaning that a chemical reaction that has producer freight can return to its original state. While dynamic equilibrium, a simple is when boiling water and then the resulting water vapor will change again to water. Okay, this chemical equilibrium has the following characteristic. 1. Occurs in a reversible chemical reaction. 2. Is dynamic. 3. The reaction continues even though it seems to have stopped. It is also said that there is no change macroscopically. 4. All components remain. 5. It can be said to be in equilibrium if the rate of reaction to the right is equal to the right. 6. The reaction is to the left, so that the ratio of the concentration of the reactants and products remains the same. As previously explained, the equilibrium reaction from of A and B and products C is from this description. Chemical equilibrium occurs when the rate of reduction of A and B is equal to the rate of increase of C in accordance with its characteristic, even though it occurs only for a moment and appears to stop. Actually, at the microscopic of invisible level, it is still carrying out reaction. This equilibrium will not remain constant if the action taken after the reaction are already in a state of equilibrium. Henry Louis Leclerc stated that an equilibrium is given an action, then the equilibrium will react and will reduce the effect of the action. Therefore, there are several factors that can affect the balance, namely volume. When equilibrium is added volume, the equilibrium will tend to move in direction of the reaction, which has the greater coefficient. Conversely, when the volume is reduced, the result is that the equilibrium will shift in the direction of the reaction with the smaller coefficient. An example is when the reaction of nitrogen and hydrogen are equilibrated and then produce ammonia. The form of the equilibrium is pressure. Pressure can also affect a chemical equilibrium. This is because when an equilibrium is given greater pressure, the equilibrium will shift to a reaction with a smaller coefficient, even vice versa. So when the pressure is reduced, the equilibrium will begin to shift to the reaction with a larger coefficient. Temperature can affect chemical equilibrium because when the temperature in chemical equilibrium is increased, the direction of this equilibrium will shift to compounds that absorb endotherms. Conversely, when the temperature drops or is lower, the equilibrium will shift towards compounds that release exothermic heat. Concentration and can affect the chemical equilibrium when it is added to one of the reactants or products, so that the chemical equilibrium will shift in the opposite direction. So for example, when concentration is added to a reactant, the equilibrium will shift to the products, whereas if concentration is added to the product, it will shift to the reactants. The equilibrium constant is a number that describes the ratio between a product and a reaction when a chemical equilibrium reaction is given action or action. The equilibrium will shift in the other direction and will change the composition of the substance so that it can reach its equilibrium again. The equilibrium constant, the ratio of the molarity product to the product molarity. Product raised to the power of the coefficient. Regulates blood pH in the body. Normal blood pH in the body is 7.4. The position must be maintained so that it remains the same. To maintain this pH, blood needs a buffer solution in the form of carbonic acid or H2CO3. Meanwhile, blood plasma contains carbon dioxide or CO2. When carbon dioxide and carbonic acid react, they maintain the pH of the blood. Oxygen binding cycle in the body. The human body needs oxygen to carry out its function. Oxygen in the body will then be bound by hemoglobin. The oxygen binding process can be described by the following equilibrium reaction: Hb plus O2, HbO2. Then the oxygen is transported by hemoglobin to the lungs. Thus, the longer oxygen will increase in the blood. Meanwhile, in the lungs there will be an equilibrium where when oxygen is the tissue, it will shift to the left. The process of equilibrium to the left will produce oxygen, which can be used for the combustion process. Okay, thanks for watching, and don't forget to like, comment, and subscribe. See you.